Questions 1 and 2 in Chapter 8 are asking you to identify the property of a gas that is measured in each of these different cases. There are really 4 different properties of a gas that affect how that gas behaves. And those 4 are pressure, volume, moles, that's the number of molecules, and then temperature. If you know those 4 things, you can predict how a gas is going to behave. Now, something that's going to be really useful in these problems is being able to associate these different properties with units. So pressure is usually measured either in atmospheres, that's the amount of pressure that a column of air from sea level to outer space exerts on a person at sea level. You don't think about it, but we live at the bottom of an ocean of air, and all of that air is constantly pushing down on us. If you're at the beach, a column of air that's pushing down on you from the ocean to outer space, that's an atmosphere. Another unit for pressure is millimeters of mercury, and that has to do with how much the pressure would push up a column of liquid mercury through a tube, how many milliliters it would push the mercury up. So those are the units for pressure. For volume, you would want either liters or anything related to it, so like milliliters, something like that. For moles, now usually the unit for moles is moles, but you can also have moles in disguise. If you ever have grams, you can always convert it to moles using the molar masses on the periodic table. Remember that for each box in the periodic table, the number at the bottom is the number of grams in 1 mole of that thing. So you can always convert from grams to moles using that, as we've seen in previous problems. And then last but not least is temperature. Now temperature in science will either be measured in degrees Celsius, and the unique thing about degrees Celsius is it's based on water. Water freezes at 0 and boils at 100, so those numbers were chosen because of water for degrees Celsius. But the one that really makes sense is Kelvin, because 0 Kelvin is absolute 0. You can't get colder than that. So either of those 2 units would indicate that you're dealing with temperature. Okay, so we'll go through each of these and identify which property is being talked about. And we see here is a capital K, so that means we're dealing with this 4th property, the temperature. Oops. So there we have that temperature, actually. All right, so there we have the temperature because A is Kelvin. That capital K is telling you Kelvin, and so that is temperature. All right, how about B? In B, we see that we're dealing with milliliters, and milliliters is a volume. So B, the property that B is telling you about is volume. All right, for C, we see that C is giving us grams of oxygen, but still grams. And the unit that grams tells you about is the number of moles. Ultimately, that's moles in disguise. So grams is really moles in disguise, so that's what that's telling us about. For D, we see millimeters of mercury. And so for millimeters of mercury, that's a pressure. That's the property of a gas that's telling us about, pressure. All right, 2 is pretty much the same thing. So we see here this is 425 Kelvin. That capital K, Kelvin, is a temperature. So when we see that, we're going to say, all right, not a problem. We're looking at temperature there. For B, we see ATM. That stands for atmospheres. Atmospheres is a pressure. So we can know, once we see that, 1 atmosphere, okay, we're talking about a pressure. For C, we see capital L, that stands for liters. And once we see liters, we know that the property of the gas that we're talking about is the volume. How much space does the gas take up? We know that it's volume because it's measured in liters. And last, we see moles here. So moles. Moles is just telling us how many moles we have, so how many atoms or molecules of the gas we have in moles. And so, based on those units, you can tell what property of a gas is being talked about.